You will recall from our Department of Defense model that the protocol TCP is found in the transport layer and IP is in the Internet layer. TCP IP is short for Transmission Control Protocol, Internet Protocol, and these are the two main protocols in a set of protocols which allow network communication to occur. TCP IP dictates how information should be packaged into small packets of data before they are sent, and then at the correct destination how these packets should be reassembled in the right order. TCP IP requires little central management, as each router on the network checks the IP address of each package to determine where to forward the message. TCP IP is designed to make networks reliable, with the ability to recover automatically from the failure of any device on the network. So, in short, TCP IP is used because it's reasonably efficient, checks that transmission of the message is error-free, uses error-checking methods on the data at the destination to ensure data is uncorrupted, and has the ability to send large amounts of data across sometimes unreliable networks. Here are the jobs TC protocol does at the source, also called the sending end. It breaks the message into small packets, and it numbers and puts the source and destination address on these packets. At the destination, the jobs TC protocol does is that it checks the data has not become corrupted, and it places these packages into the correct order. The TCP protocol is only active at the source and destination end. The Internet Protocol, IP, is used for addressing and routing of the packages and ensuring that each package takes the most efficient route. IP is only active when the packages are being routed. It works by each package coming to a router. If that router has the exact address, it will pass that package onto the destination address. If, however, a router only has a partial address, it will pass the package onto the next appropriate router. IP addresses can be expressed in two formats, either as IP version 4 or IP version 6. An example of an IP version 4 address is this: 16.48.125.145. This IP is 32 bits in length. On your screen you can see the same address if it were written as bits. Notice there are 8 bits between each dot, so 4 sets of 8 make 32 bits. The IP version 4 address is similar to a street address, but in reverse order. So here is the address of Joe Bloggs if it were written on an envelope. Mr. Joe Bloggs, 18 Crawshaw Avenue, Tapping, Perth. If this were an IP address, it would be written as this: WA, Perth, Tapping, 18 Crawshaw Avenue. So the first 8 bits of an IP version 4 address are referred to as Class A and is addressed to large networks. The second set of 8 is Class B, which is for medium-sized networks. Class C are for smaller networks, and Class D are for computer devices on a network. Here is a quick recap of the features of IP4. We have the example 216.27.61.137. Each number is separated by a dot, also called a period, and it's a 32-bit system. Each decimal number is an 8-bit binary code, and the available addresses are 4,294,967,296. The big problem with IP version 4 is that we now have completely run out of these addresses. The solution is IP version 6, and here are the features for IP version 6. On the screen you will see an example. These are hexadecimal numbers, which are separated by colons, and this is a 128-bit system. It's faster and more secure than IP version 4 as it has built-in encryption. It also allows one device to have many network addresses. And there are 34 decillion available addresses using IP version 6. That's 34 with 36 zeros after it. As you can see, IP version 6 has some obvious advantages. There are lots more addresses available and we are unlikely to run out. Since IP version 6 is a 128-bit system, it's far less hackable. And the type of security built into IP version 6 is IPsec, which is an encryption protection at the packet level. This packet level security is during transit and is particularly useful for gaining access to a network, for encrypting data on a server, or storing data on a network-attached storage device. That concludes our talk on TCP IP protocol. Thank you for listening. Bye-bye.